Hi guys, welcome back to my channel, and let us quickly solve this math Olympiad problem. Okay, this is a simultaneous equation, and then let us quickly solve that. But before we solve this, please, if you're new to our channel, please subscribe. Then you can like the video at the end of it. If it's worth it, then you comment as well what you think about the video. Now, don't forget we bring you math, physics, chemistry videos. To solve this is very simple. What do? We just apply the laws of indices. Now, the first one, let us say, let's multiply. Let's call this equation 1 and 2, okay? So solution, okay, let me write solution. So I have that equation 1 is, okay. Let me call this one equation 1 and this equation 2. So let me decide to write this first. 2 raised to power y times 2 raised to power x is equal to 18. Let me call this one equation 1, and then 2 raised to power x times 3 raised to power y is equal to 12. Let me call it equation 2. Okay, now if I decide to multiply equation 1 and 2, this time this will give you 2 raised to power y times 2 raised to power x, okay, then times, here now I'm going to have 2 raised to power x times 3 raised to power x times 3 raised to power y is equal to, this time this will give us 18 times 12 will give us 216. Right? Now, if you remember, according to indices, that if you have a raised to power m times a raised to power n, if the base are the same thing, we can just add the power m plus n. All right? Do you still remember this? So let us apply it here. I'm going to have that this is 2 raised to power y plus x, okay, times 3 raised to power, is there a problem? Sorry, this is y raised to power this, and this is 3 raised to power x. Okay, yeah, so this is 3 raised to power x plus y is equal to 216. All right, now don't forget that 2 plus 3 is still the same thing as 3 plus 2. Okay, if you know this, so let us swap this. This is now 2 raised to power x plus y, right, times 3 raised to power x plus y is equal to 216. Now, according to indices, you should know that a raised to power m times times b raised to power m. Now, if they both have the same power, we can put it in bracket of a times b, then raised to power m. Okay, so if you know this, now let us apply it here. You see that the power here are the same thing, so I can have it to be 2 times 3, have it to be 2 times 3, then everybody raised to power x plus y is equal to what? 216. All right, this time this will give you 6 raised to power x plus y is equal to 216. Now let us break this down. By breaking this, I'm going to have 216 divided by 6. What do you have? Divided by 6, I'm going to have 36. Then 6 again, I have 6. 6 again, I have 1. Now this is 6 raised to power x plus y is equal to, now I'm dividing with 6 and they are 3 in number. So this is 6 raised to power 3. Now according to indices again, you should know that if you have a raised to power m is equal to a raised to power n, that the base can take care of each other, then the power is the same. Okay, sorry, m is equal to n. So if this base cancel out, I'm going to have that x plus y is equal to 3. Let me call this equation 3. Now, calling this equation 3, coming back to this, our equation 1 and 2, let us decide to divide them and see what we are going to have. Okay, so if I have division here, let us divide equation 1 and 2 and see what we are going to have. Now, this is going to be 2 raised to power y divided by 2 raised to power x times, if you come to this place, I'm going to have 3 raised to power x divided by 3 raised to power y is equal to what? 18 divided by 12. Okay. Now, according to the law of indices, I told you that what we are going to be applying here is just the law of indices. Okay. And the law of indices say that if I have a raised to power m divided by a raised to power n, as far as the base are the same thing and you have division, you just subtract the power m minus n. Okay. So this is what we are going to apply here. This divided by this will give you 2 raised to power y minus x, all right, times this one will give us 3 raised to power x minus y, okay, is equal to, coming to this place, I'm going to have 18 divided by 6, that is 18 by 12. I'm going to have 3 over 2, 3 over 2, all right. So now what do? The same thing we did here. Now you should know that now I want to make this to be in the same x minus y. So what do? So do you know that this is look at this. This is 2 raised to power. If I put minus here and then put bracket x minus y, let's check. Okay, minus times x will give us this minus x, and then minus times this will give us plus y. Okay, so I didn't change anything. Times 3 raised to power x minus y is equal to 3 over 2. Okay, now according to indices again, you should know that now this is same as saying minus 1 here. Okay, this is same as saying minus 1. So this is same as saying minus 1, and according to indices, do you know that 2 raised to power minus, okay, even if you don't want to put minus 1, let us say 2 raised to power minus m is the same as saying if you want to remove this minus, it's going to be 1 over 2 raised to power m. Okay, so let us apply it here. So for us to remove this minus, I'm going to have 1 over 2 raised to power x minus y, right? Then times 3 raised to power x minus y is equal to 3 over 2. Okay, so now having this, we're going to see that anything times 1, let me make this over 1. This time this, I have 3 raised to power x minus y, then over 2 raised to power x minus y is equal to 3 over 2. Okay, let's still apply the law of indices again that say that if you have a raised to power m divided by b raised to power the same m, okay, that it could be written as a divided by b, then everybody raised to power m. Okay, so let us apply it here. So this is same as saying 3 over 2, then everybody raised to power x minus y is equal to 3 over 2. And 3 over 2 can be written as 3 over 2 raised to power 1. Okay, so if you know that, you are going to see that the base are not the same thing, so they can cancel out. Don't forget again that indices said that a raised to power m being equal to a raised to power n, that they can just cancel out, and therefore m is equal to n. So if these two cancel out, I'm going to have that x minus y is equal to 1. Equation 4. Okay, equation 4. So now we can now solve equation 3 and 4 simultaneously to get our x and y. Don't forget that in our equation 3, we got that x plus y is equal to 3. Then our equation 4, we now got that x minus y is equal to what? 1. So if we solve equation 1 and 2 simultaneously, let me just subtract. This minus this is gone. This minus this will give you 2y is equal to what? 2. Therefore, y is equal to 2 divided by 2, which is 1. Okay? So anyway, I see y in equation 3 or equation 2, I can just substitute equation 4. Equation 4 says that x minus y is equal to 1, and I have that y is 1. So x minus 1 is equal to 1. So therefore, x is equal to 1 plus 1, and x is equal to what? 2. So therefore, my answer, x is equal to 2 and y is equal to 1. So that is that. Now, let us check if it is very correct. We got x to be 2 and y to be 1. Okay? If our x is 2 and our y is 1. Let us check here. I have that 2 raised to power 2 times 3 raised to power 1. Let's see if we get 12. 2 raised to power 2 is 4 times 3 raised to power 1 is 3. And 3 times 4 is 12, which is the right hand side. So 12 is equal to 12. So this one is correct. Let's check the second one again. For the second equation, we have that 2 raised to power y times 3 raised to power x gave us 18. So let us now substitute. 2 raised to power 1 times 3 raised to power 2. Is it the same thing as 18? Let's check. 2 times 9, is it 18? Yes, 18 is equal to what? 18. So that is that for that. Thank you very much for watching this video. Please don't forget to like, comment, and subscribe if today is your first day of seeing our video. May the peace of the Lord be with you.